So we just computed an example using the one sample t test, or one sample z test is what we call it. So we only have one sample and we're using z values. Now, when do we use the z values? Well, when we have relatively large samples, we had 35 observations. So that's bigger than 30. Kind of 30s are cut off for whether it's a big sample size or a small sample size. And we also knew the true standard deviation of the population. So those two, we used the z-test. But if we have a large sample size, but an unknown standard deviation of the population, we can actually substitute values into our sample standard deviation. So we can actually, or we can substitute values to use our sample standard deviation. So the difference between these two equations here are nothing more than using sigma or s. So this is the sample standard deviation. So these, we want to use the z-test if our observations are relatively large or our sample size is relatively large. Okay. If our sample size becomes small, all right, and sigma is unknown, we use the one sample t-test. And it's computed very similar to the z-test, but we do not know sigma, so we use our sample standard deviation here. And then we get values for t instead of z. And the test, or to look up t values in the table, you first need to know the degrees of freedom. And remember, we said the degrees of freedom, this v value is equal to n minus 1. So our sample size minus 1. So to be able to look values up in the table, we need to compute the degrees of freedom first. And then our test criteria looks very similar to the z-test, but instead here we're using t values, the t distribution, instead of the z distribution. But the criterion for rejecting the null hypothesis looks very similar. And in these, if it's greater than or less than for the alternative hypothesis, we call these one-sided tests. And then if it's not equal to, we call this a two-sided test, because we're actually, in this case, in the example we went over, we're actually looking at both tails on both sides. But for these two tests, we'll only look at one side of the distribution curve here.